Good evening, students. Today we are going to discuss about the another important built-in module of Python is math module. So using which you can perform the arithmetic operations and then you can perform the some of the trigonometric operations also. So let's see what we can do with the help of this math module. What sort of built-in stuff is available under math module. First we will see what sort of math variables it is going to provide. So we all aware the first one is pi. So the pi value we know 3.14. So this pi is the important variable here. So using this math.py, wherever you want to use that the constant 3.14, there you can use this math.py. Math.py. Now then after the next one is the exponentiation, that is what the e value, that is the 2.71. 3.14, 3.14 and 2.71. And whenever we have any data where it is represented is not a number, then we can use NaN. Then the math module is also supports the INF, and one more the variable as TAU. TAU. Yeah, you can check all these values. So here the pi value, E value, and this is what, not a number. The not a number is represented with the help of the what, INF. And so whenever you want to represent any infinite, then we have math.inf, and this is what, TAU. Now you can see the values. So wherever you need these values, you can use those constants. You can use those constants. You can use those constants. See, right now, if you see here at the top, pi value, e value, not a number, infinite, and TAU. Now we will see the one by one the mathematical functions which are supported by math module. Math module. Right. We will see one by one. So the first mathematical function we are going to discuss under math module is print. So let us discuss what are the trigonometric functions it is going to support. So sine function, math dot sine. So we all aware what is the sine 90 value. Now we will calculate the sine 90 value. See, the sine 90 we got it as what? 1. The sine 90 we got it as what? 1. So what we have done, we have displayed the sine 90 value. So the 90 degrees you are going to represent pi by 2. The pi by 2 is represents the what? 90 degrees. So sine 90, it is giving the what? 1. Right? Now similarly we can see the other mathematical trigonometric functions. Yeah, cos 90 you want to print, then math dot cos math dot pi by 2. This is, you can see now what is the value of the cos 90. So the cos 90 is what? This is what the value we got. Now similarly you can also check what is the tan. It will also supports the word tan function also. You can have math dot tan math dot pi by 2. Now we are going to see what is the value for the tan 90. Right, so this is what the value for the what? Tan 90. Now similarly if you want to access some other, yes, you just change the denominator so that you can print the 30 degrees, 45 degrees, like that you can access this trigonometric function. So if you need the cosecant, just you apply the 1 by sign, that is what the cosecant. If you need the secant, you just apply the 1 by cos, that is what secant. Similarly if you need the cot, you just apply the 1 by tan, you will get the cot. You will get the what? Cot. Now the basic trigonometric functions we have covered. Then what else you can perform is, now I want to check the reminder. So math dot reminder. So 2 comma 3. When the 2 is divisible by 3, what is the remainder we are going to see? The first argument is see, the remainder is what? Minus 1.0. Minus 1.0. Here the remainder function 2 comma 3, what it is giving? Right, minus 1.0. Now let us change it as 10 comma 3. 10 comma 3. So if you give 10 comma 3, it is giving the what? 1. See here it is a what? Floating point value. Floating point value. So these are all the things I am taken off. Just we can see the rest one by one. Now here you have to understand one thing. The moment I have given, for example, 4 comma 5, it is not going to give 4, rather than what it is giving? It is giving minus 1.0. That is what you have to understand. Whereas our mathematics generally, 4, when the 4 is divisible by 5, what is the remainder we will show? The remainder we will show is what? 4. But whereas here it is giving minus 1. Now for example 123. So this 100 is greater than 23, right? Whatever the actual remainder is there, that actual remainder will be shown there. It won't shown in negative values. But when you mention this one as 100, and here if you mention it as a 230, you can see the negative value. Yeah, the remainder now what it is showing 100 100 230. Now for the 100 comma 230, what it is showing? It is just showing 100 only, whereas just now we have seen for the smaller examples what it is showing. Run module 1 comma 2, it is 1.0. Whereas the difference you have to identify, when I give 4 comma 5, it is giving minus 1. It is giving minus 1, minus 1.0, minus 1.0. So this is what about the remainder function. Now let's see the next function. Print math dot copy sign 4 comma minus 4. Now whatever the second argument sign is there, that will be copied to the first argument. Yeah, for differentiation you can take the first argument as different. Now it will give the minus 10, right? So if you want to copy the sign of the second argument, then you can use the what copy sign function. What this copy sign function will do, whatever the sign is there for the second argument, that will be copied to here. For example, here we have the minus 1 and here we have the plus 4. Let us see what is the result now. Now the copy of the second argument is copied to the what first argument. Now what's happened, it has been converted into what negative. Now let us say both are negative, then anyway that is negative and the second argument is negative, so whatever the second argument sign is there, that will be carried for the first argument, that will be carried for the first argument. So that is what copy sign method. So then after you have the another important, the factorial method. So if you want to calculate the factorial of the given number, you can use the factorial method. 5 factorial 120 will be given. See, so here it is printing what 120. Now if you give the 0 factorial, it will give 1. 0 factorial is what 1, right? 1. So when you're trying to provide any negative sort of stuff, then see definitely it will throw an error. We cannot calculate the factorial for the negative number. See, factorial can't be defined for the negative values. Factorial can't be defined for the negative values. And similarly, we can perform the other the functions, like we can calculate the LCM. We can calculate the LCM. Now I want to find out the LCM of the given 5 numbers 1, 2, 3, 4, 5. The least common multiple. Just run it. So it will give 60. It will give 60. Similarly, if you are changing the values, yes, you can pass as many, then it will calculate, then it will give the LCM values for the given numbers. Whatever the arguments you have passed to the LCM function, for that values it will calculate the LCM and then it is going to display. Similarly, you can calculate the GCD of the given numbers. The GCD of the given numbers, no matter how many arguments you are giving, it is going to print the greatest common divisor for the given numbers. The greatest common divisor for the given numbers, that is what the GCD function. Now you have the power function also. So the power function, the first argument is the base, the second argument is the exponentiation. 2 power 3 means we will get the 8.0. 8.0, and here you can also pass the what floating point values also you can pass, which will work for the floating point values also, which will work for the floating point values also, right? Either you can pass the integers or you can pass the floating point values also. Similarly, there is a one more function which is supported, exponentiation. E power 3 you want to calculate, so when you run it, the function name is exp of 3, e power 3 value. So this is what the e power 3 value, right? Now similarly, you have the logarithmic functions also. This is log e100. When you not mention any base, it will be calculated for the e. So the log 100 is what 4.605. Similarly, you can apply for log 10 also. When you apply for the log 10, it will give it as what 2. It will give it for what 2. So this is what 2.0. 2.0. Similarly, there is another function here. You can convert the degrees. Now I want to convert the radians into generally the pi value is what 180 degrees. Now so let us see whether it is giving the 180 or not. Now that pi I am converting into degrees. Yes, 180 degrees. Similarly, you can convert the degrees into uh, radians now. So you can use the radians function. So in the radians function you can give 180, so that you will get the what 3.14. you will get the what? 3.14. So there is a radian function is there, there is a degrees function is there. So if you want to convert the radians into degrees, you can use the degrees function. If you want to convert the degrees into radians, you can use the radians function. Now what else you can perform is, uh, see, there is another, you can also find out the square root. You can also find out the what? Square root. For example, square root of 4, right? 2.0. Similarly, there is a one more function, it is going to support cube root. So the cube root of 4, if you want to calculate, you can give CBRT, it will give cube root. It will give cube root. And what is the other stuff is there? We can see one by one function. Now this cos SQRT, and coming to this one, so when you want to calculate the Euclidean distance between the 2 points, this you can use, right? So now let us discuss about this Euclidean function. Now, if you see this Euclidean function, we all know what is the formula for the Euclidean distance. You can take the n-dimensional point or the two-dimensional point, which will calculate the Euclidean distance between the 2 points. Now, run module, so which will give the what? The Euclidean distance. Now similarly, the next function you can see, if you want to calculate the absolute value, you can use FABS function. So whatever the value you are going to pass, it will be converted into positive only. That is what the absolute value function. Definitely it will give the what? The positive value. Yeah, so I haven't mentioned that math. So math dot FABS. So everything will be converted into what? Positive. So now it has given what? 4.5. So that is what? FABS function. And we have also seen the what? Factorial function. Now the another important thing which you have to understand from the math module is floor and sail function. Now floor of 3.1 will give the what? 3. So the lowest integer, right? So for the 3.1, what is the lower bound? 3. That is what. Similarly, when you need the upper bound for this 3.1, this one will give the what? 4. This one will give the what? 4. Right? Clear? So this is what. Similarly, you can also have the round function. So round 3.1. So let's see what's happened. So round 3.1. Yeah, math doesn't have the round function. Oh, sorry, it doesn't support round function. Now, similarly, the f mod function is reminder, like your reminder function, but where you can use the what? The floating point values also. 3.1, then run module 2.1. This is what about f module. This will also give the what? Reminder. This will also give the what? Reminder, right? Then if you want to calculate the sum where the values were mentioned in a iteratable or the collection variable, you can use the fsum function, which will calculate the sum of all the values in the list or the tuple you have provided. That is what the fsum function. And we have also seen this GCD, right? So the GCD function also we have seen. Now coming to the this you all know right angle triangle, for which generally we will calculate the hypotenuse. We all know the formula for the formula using the Pythagoras theorem. The same thing we are done with the help of the hypotenuse. See, so now it has given the value. So here if you provide the two values, then one will be taken as a one side, the another will be taken as another side, so that the diagonal will be calculated. See, 2.23, 2.23. Now the another important function under math module is, you want to know whatever the number you have pass it to a you are now getting a one number, you want to check whether the number is finite or infinite. So there is a method is finite is there, one is a finite value, right? So definitely it will return the what? True. Definitely it will return the what? True. Similarly, I told you the LCM is used to calculate the least common multiple, the log is used for the logarithmic, and the next two important things we can apply, the permutations and combinations. The permutations and combinations. So we can apply these permutations and combinations. Let us see. So we need the what? N value and K value. NCK and NPK. NCK and NPK. So those permutations and combinations you can do with the help of these two functions, right? One is the 0, the another one is what? 4. So this is what is about the math module. In the next class we will see the next module.